If you've ever watched a modern factory floor in action, with robotic arms moving at absolutely blinding speeds and bottles just flying down a conveyor belt with zero errors, well, you're watching sensors at work. They act as the crucial first step in literally any modern system. Because before a machine can act, it has to know what's going on around it. So today, let's uncover exactly what sensors are in automation and why they form the heartbeat of the industrial world in this comprehensive explainer.
Here's a super quick look at our roadmap. We're going to cover 1. Sensors, intro and working. 2. Sensor types and outputs. 3. Sensor and PLC integration. 4. Applications and benefits. And 5. Mistakes and future tech.
All right, let's jump right into Section 1, Sensors. Intro and working. Understanding the basics of industrial sensors.
To put it simply, a sensor is a fundamental device in automation that detects and responds to physical inputs from the environment. Think of it this way. Human observation is great, right? But it's slow, we get distracted, and we tire out pretty easily. Sensors replace that slow human observation with lightning-fast, incredibly accurate detection. They effectively serve as the eyes and ears of a machine. Without these digital eyes and ears, honestly, the most advanced robotic arm in the world is essentially blind. This detection is the absolute bedrock of automation. So how does an object just existing trigger a machine to move? It's a pretty fascinating 5-step journey. First, the physical object triggers the sensing element. Next, that raw data undergoes signal processing right inside the device. Step 3, it's converted into a readable electrical output. For step 4, that output travels as an input to the PLC, which is the programmable logic controller, or basically the brain of the operation. Finally, step 5, the PLC reads that signal and triggers the machine response, like maybe pushing a defective product off a conveyor belt. And the craziest part, this all happens in milliseconds. Now, underneath that plastic or metal housing, there are 5 key internal components working in perfect harmony. You've got the sensing element that physically interacts with the environment. Then there's the transmitter and the signal conditioner, which are there to clean up and boost the raw data. You have the output circuit that preps the signal for the outside world. And of course, the power supply, keeping the whole shebang alive. And this is all packed into a device that can sometimes be smaller than your thumb. Moving on to Section 2, Sensor Types and Outputs. Exploring categories and electrical signals. We can broadly group these devices into 2 massive categories, the first being position and object detection sensors. These are primarily used for detecting where objects are and if they're present on the line. For example, inductive sensors detect metal parts. Capacitive sensors can kind of see non-metals like liquids or plastics. And photoelectric sensors use light beams to catch a box crossing a path. We even have vision sensors acting as miniature quality control cameras and encoders that track the exact rotational position of a motor. The second major group contains environmental and measurement sensors. Because, we don't just care if an object is there, we also need to know the conditions of our environment. Is the boiler too hot? Well, we use specialized temperature sensors for that. How much water's in the tank? We rely on level and pressure sensors. We measure flow, humidity, hazardous gases, and we even use load cells to track weight. These sensors ensure the factory doesn't just run fast, but runs safely and precisely. But how do these sensors actually talk to the system? Well, on one hand, we have digital outputs. This is simple on-off logic. Yes or no, 1 or 0. In the industrial world, this is often handled via specific transistor wiring called PNP or NPN, which really just dictates how the circuit is switched. On the other hand, we have analog outputs. These provide a continuous range of data, not just on or off. For example, a temperature sensor might send a continuous 0 to 10 volt signal or a 4 to 20 milliamp signal, where the voltage or current rises smoothly as the temperature rises. That brings us to Section 3, Sensor and PLC integration. Wiring the sensors to the brain. And that brain is the PLC. Sensors physically wire directly into the input cards of the PLC. Depending on what we just learned, they send either those digital on-off inputs or those continuous analog inputs. The PLC acts as a massive decision-making engine. It constantly reads all this fundamental data, runs it through the programmer's customized logic, and decides what outputs to turn on. If the analog temperature sensor reads too high, the PLC logic dictates that the cooling fan turns on. It's just a perfect continuous loop of data and action. Let's hit Section 4, Applications and Benefits. Seeing sensors in the real world.
This technology is incredibly versatile across so many different industries. In a bottle filling plant, photoelectric sensors ensure a bottle is perfectly aligned before liquid pours. In CNC machining, precise encoders track millimeter-perfect tool movements. Water treatment plants rely heavily on level and flow sensors to prevent overflows. Even in smart agriculture, humidity and soil sensors determine exactly when crops need watering. From food and pharma all the way to home automation, sensors are the quiet workers making our modern world possible. The operational benefits here completely transform a facility. By implementing sensors, factories achieve highly accurate, high-speed operation that humans simply cannot match. This drastically reduces human error, which directly leads to massively increased productivity and way better quality control. But it's also about safety and efficiency. Sensors keep workers safe from moving parts, they enable predictive maintenance by catching a vibrating motor before it breaks, and they save immense amounts of energy by only running machines when absolutely necessary. And finally, Section 5, Mistakes and Future Tech, Common Pitfalls and What Lies Ahead. I do want to caution you here, because even the best engineers can fall into these 5 common traps. First, wrong sensor selection, like using a standard optical sensor in a highly dusty environment where it just gets blinded. Then you have wiring mistakes and improper mounting, where vibration literally knocks the sensor out of alignment. Electrical noise interference is a huge one too. If high-voltage cables are too close to sensitive analog sensor wires, the signal gets corrupted. And lastly, calibration issues. If the sensor isn't tuned to the baseline environment, it's going to feed the PLC bad data, and your smart factory suddenly becomes very confused. It can completely ruin an otherwise perfect automation setup. But looking ahead, the tools to overcome these issues are already arriving. The cutting-edge advancements driving Industry 4.0 are incredibly exciting. We're moving away from dumb sensors that just send an on-off signal towards smart sensors and edge AI sensors that can actually process data internally and self-diagnose problems. We're seeing IIoT, the Industrial Internet of Things, bringing wireless sensors to the factory floor, completely eliminating complex wiring runs. The future is definitely a connected, AI-driven mesh of sensors communicating in real time. Based on the source material we're covering today, we also want to neutrally note the provider behind these insights. DEVI Automation Solutions offers a wide range of services in this sector. This includes industrial automation, PLCs, touchscreen interfaces known as HMIs, large-scale SCADA monitoring systems, and motor control programming. They also work with AI and IIoT integrations, smart agriculture, home automation, and solar solutions. For those looking to explore business inquiries related to the technologies discussed, they can be reached at dvautomationsolutions@gmail.com. That leaves us with a truly fascinating landscape to consider. The days of a sensor just being a simple switch are officially over. As sensors become smarter, self-calibrating, and directly powered by AI at the edge, what incredible new possibilities will Industry 4.0 unlock for the future of global manufacturing? Are we looking at factories that can entirely fix and optimize themselves on the fly? It is an amazing thought to ponder. Thank you so much for joining me on this explainer. Keep learning, and we'll see you next time.